Okay, in this video, we're going to solve this problem right here, and so let's begin. So if we plug in infinity here and infinity there, you essentially just get infinity minus infinity. And that's a red flag that you need to approach this problem differently. And so what I'm going to do is multiply by the conjugate, and I'll show you what I mean by that. So this piece right here remains the same. The square root of x raised to 4 plus 3x squared. Instead of a minus, you're going to do the opposite. You'll say plus, because you're multiplying by the conjugate. Parentheses x squared plus x, close it. If you do it on the numerator, you also have to do the exact same thing on the denominator. So next we can multiply it out. We get the limit as x approaches infinity. And so what we're going to do is take this piece times this piece, and they're identical. So the square root is going to cancel. So we'll get x raised to 4 plus 3x squared. Then we're going to take this piece and multiply by this piece. Likewise, this is the opposite, negative this piece times this piece. So they're opposite, they just cancel out. So there's no point in even expanding because they'll cancel out. Because again, this piece times this piece is the opposite of negative this piece times this piece. And because they're the opposite, they just cancel out. And the last thing we need to do is take this piece and multiply by this piece. So we can just say negative parentheses x squared plus x, close it, times x squared plus x, close it, divided by our denominator. Next, we can kind of expand it out. So we have the limit as x approaches infinity. So the top, we're still going to keep x raised to 4 plus 3x squared. Then we got to expand this piece out. I'm going to keep the negative. I'll put a parentheses, and I'll expand these two things. So x squared times x squared is x raised to 4. X squared times x is going to give us x cubed. X times x squared gives you x cubed again. X times x is x squared. Close parentheses, divided by our denominator stays the same. So now we're going to distribute this negative to all the pieces inside the parentheses. So we have the limit as x approaches infinity. For the top we have x raised to 4 plus 3x squared minus x raised to 4 minus x cubed minus x cubed minus x squared. Again, we're distributing this negative to all the relevant pieces. Divided by this piece right here, we have the square root of x raised to 4 plus 3x squared plus x squared plus x. So let's clean it up. So x raised to 4 minus x raised to 4. It cancels. So we have the limit as x approaches infinity for our highest power, negative x cubed, so we get negative 2x cubed. Next highest power, we have 3x squared minus x squared, so we get a plus 2x squared, divided by this piece right here. Now, because we're working with infinity, x is approaching infinity, all we really care about is the highest power. In our case, x cubed for the numerator, so we could say we have the limit as x approaches infinity for negative 2x cubed divided by, so here the highest power is x raised to 4, but we take the square root of it. So it's like the square root of x raised to 4, and then here the highest power is plus x squared, so put plus x squared. And we know the square root of x raised to 4, that's like, x squared. So we have the limit as x approaches infinity for negative 2x cubed divided by like 2x squared. So if we clean it up once more, we get the limit as x approaches infinity. The 2's cancel. X cubed divided by x squared. So we just end up getting a plain negative x. Because the 2's cancel, this is x cubed, this is x squared. So it's like 3 minus 2, which is raised to 1. So just x. And now if we plug in infinity here, we end up getting negative infinity. This right here is your final answer. That's all you need to do for this problem.